Find the volume of the solid when the region bounded by y is equal to 1 over x, y equals 2, and x equals 2 is rotated about the line x is equal to 2. Well, let's get started by drawing in our axis of rotation, which is x is equal to 2. So that's right here. And it's also bounded by y is equal to 2, so that's also a section that we're going to take into account with our graph. And then we have the function y is equal to 1 over x. Well, we know that this function, when graphed, it will have at the point, or x value of 1, it'll end up outputting 1. If we input 2, it'll output 1/2. If we input 3, it'll output 1/3. If we input 1/2, it'll output 2. So you kind of get an idea of what this is going to look like. It's going to look like this. And we don't necessarily have to connect these, but it kind of gives you an idea of what it will look like. And it'll continue getting closer and closer to the y-axis as we keep going up as well. All right, so then it's bounded by this curve and these two axes. So we have this area that we are then going to rotate about the line x is equal to 2. So it's going around like this. So when it's coming out of the page and then over to this side, it's gonna look something like this on the other side. So as I said, it starts on this left side, comes out of the page, and then over to the right side of the asymptote, and then it goes into the page. So you have this shape or solid rotation that's going on here. And here's our radius that we have. So now looking at our graph that we have, because we have a vertical axis of rotation, we're going to have to integrate with respect to y. Well, right now we have that y is equal to 1 over x. So let's work on putting x in terms of y. So y is equal to 1 over x. If we cross multiply and then divide, we'll get that x is equal to 1 over y. Okay. So we're going to be using 1 over y as part of our integrand. Now the other thing that our region is bounded by, like this is the x is equal to 1 over y, is this lower part. The upper part is this y equals 2. So the integrand is going to be 2 minus 1 over y. And we're going to square that because that's our radius. Then we have to determine the lower and upper bounds, and we're going to multiply by pi, and this will end up giving us our volume. Well, if we look, as we go up and down this axis, we go all the way up to 2, and we go all the way down to this point right here. Well, that's when x is 2. So if we substitute 2 in for x, set it equal to 1 over y, we can solve for y. 2y will equal 1, so y will equal 1/2. Therefore, the lower bound of integration is going to be 1/2. Okay, now let's multiply our integrand, or square it, and then integrate it. So we have 2 minus 1 over y being squared, so we can multiply it by itself. And when we do that, we will have pi times the integral from 1/2 to 2 of 4 This will be minus 2 over y minus another 2 over y, so that'll be minus 4 over y when combined together, and then plus 1 over y squared. We're going to integrate with respect to y. So we still have our pi out in front, and now let's actually do the integration. When we integrate a constant, it's that same constant with the variable right after it, so it becomes 4y minus the integral of 4 over y will be 4 times the natural log of the absolute value of y. And then plus, we could rewrite 1 over y squared as y to the negative 2. So the integral of that will be negative 1 over y to the negative first power, or negative 1 over y. So we can simplify this by removing this addition sign and replacing it with the subtraction sign, which is affiliated with this negative 1 over y. Let's do that real quick. So we have a minus 1 over y. And now we can evaluate this from 1/2 to 2. So we still have our pi that is out in front. And we're going to multiply this by 4 times 2 is 8, minus 4 times the natural log of 2, minus 1/2. Then we're going to subtract, and now we have to evaluate it, what's inside of the parentheses with the 1/2. Well, 4 times 1/2 is 2, minus 4 times the natural log of 1/2, and then minus 1 divided by 1/2 is 2. Okay, notice this 2 and negative 2 in the second set of parentheses, they cancel each other out. And we have a minus negative 4 natural log of 1/2, so that's going to become plus a positive. So now we can simplify this too. And I also realized we have an 8 and a negative 1/2 that we can combine together, so that'll be 7.5 or 7.5. So we have pi times 7.5 or 7.5 minus 4 times the natural log of 2 plus 4 times the natural log of 1/2. And now we can evaluate this in a calculator. So we have pi, and then in parentheses, 7.5 minus 4 times the natural log of 2. Make sure you close the parenthesis for the natural log so that it doesn't evaluate anything else after it. And then we have plus 4 times the natural log of 1/2. 1/2, close that parenthesis and close the other one. And when we evaluate this, we have 6 and about 141 thousandths, or answer choice C.